A 40-foot ladder is leaning against a vertical wall of a building. The base of the ladder is being pulled away from the wall at a rate of 6 feet per second. Determine the rate of change of the area of the triangle formed by the wall, ladder, and ground when the base of the ladder is 24 feet away from the wall. So looking at the diagram below, we first know the ladder is 40 feet and the length of the ladder is not going to change. This would be the hypotenuse of the right triangle. Next, the base of the ladder is being pulled away from the wall at a rate of 6 feet per second, which should be in this direction here. Let's go ahead and label the horizontal leg X and the vertical leg Y. We know X is increasing at a rate of 6 feet per second, which we express as dx dt. dx dt is equal to 6 feet per second. And again, we're using a positive 6 here because X is increasing in length. We're asked to determine the rate of change of the area of the triangle. So we're looking for dA dt when the base of the ladder is 24 feet away from the wall, which indicates when X equals 24 feet. From here, we know we're going to have to use the area formula for a triangle, which is 1/2 base times height. Or using our right triangle, we would have the area is equal to 1/2 times x times y. And now because we're looking for dA dt, we now differentiate both sides of the equation with respect to t. So on the left, we have the derivative of a with respect to t. On the right, we'll have the derivative of 1/2 xy with respect to t. I'm going to go ahead and factor out the 1/2 and write it as 1/2 times the derivative of x times y with respect to t. On the left, the derivative of a with respect to t is dA dt. Equals on the right, we have 1/2 times the derivative of xy with respect to t, which is going to require the product rule, where we have the first function of x times the derivative of the second function with respect to t, which is dy dt, and then plus the second function of y times the derivative of the first function with respect to t, which is dx dt. From here, notice to determine dA dt, we need to know x, dy dt, y, and dx dt. Right now, we only know dx dt and x. Let's begin by determining y using the Pythagorean theorem. We know x squared plus y squared must equal 40 squared, and we know we're trying to determine dA dt when x is equal to 24. So given we know that x squared plus y squared must equal 40 squared, and we know we're trying to find dA dt when x is 24, we have 24 squared plus y squared must equal 40 squared, giving us y squared equals 40 squared minus 24 squared, and therefore y is equal to the square root of 40 squared minus 24 squared, giving us y equals 32. Let's go ahead and record this above. We have y equals 32 feet when x is 24 feet. And now we need to determine dy dt when dx dt is 6 feet per second, x equals 24 feet, and y equals 32 feet. To do this, we'll go back up to our equation, x squared plus y squared equals 40 squared, and differentiate both sides of the equation with respect to t. The derivative of 2x with respect to t is 2x times dx dt, plus the derivative of y squared with respect to t is 2y times dy dt, equals on the right, the derivative of 40 squared with respect to t is 0. And now we'll solve for dy dt. We'll first subtract 2x dx dt on both sides, which gives us 2y times dy dt equals negative 2x times dx dt. And then we'll divide both sides by 2y. Simplifying, we have dy dt equals negative x times dx dt, all divided by y, which in our case we have negative 24 times dx dt, which we know is 6 feet per second, divided by y, which we just found as 32. Simplifying this gives us negative 9 halves. Or if we want negative 4.5. We now know dy dt is equal to negative 9 halves, and the units here would be feet per second. Let's go ahead and add this to our given information. Again, we now know that dy dt is equal to negative 9 halves feet per second, when dx dt is 6 feet per second, x is 24 feet, and y is 32 feet. And now we have all the information we need to determine dA dt. dA dt, which is the change in the area with respect to time in seconds, is equal to 1/2 times the quantity x, which is 24, times dy dt, which is negative 9 halves, plus y, which is 32, times dx dt, which is 6. Simplifying, we have dA dt equals 1/2 times the quantity negative 108 plus 192, which gives us dA dt equals 1/2 times 84, which is equal to 42. And again, this is measuring the change in the area with respect to time in seconds. The units here would be square feet per second. So again, under the given conditions, the rate of change of the area of the triangle is 42 square feet per second, or we can say the area is increasing at a rate of 42 square feet per second under the given conditions. I hope you found this helpful.